Assalamu alaikum guys. In today's video we are going to learn something that were left behind in my last video for the functions, and there is a special kind of function that we are going to use to generate random numbers because you see that we have made the programs to multiply one matrix with another, and we see that it's almost very tiring to input the numbers. Not so much for me, but maybe in sudden situation we face that we have to take the input so quick as a demo program. So in today's video we'll just make a program in which we'll generate random numbers, and yeah, let's get started. So random numbers generation is of two types here. So one is the pseudo-random that seems random but it's not, and there is another method that we are going to generate random number by, and in that method we are going to take help from another method that will help us generate random number in a true sense, the real random number. So as I said, the first method is of pseudo-random. To do that, I'll just delete yesterday's program. Okay. So this is pass by value and pass by reference. Just a little recap. In pass by value, when you pass the object into the function, a copy is made, not the real value has been sent into the function, and then operation is done on that copied variable. But when you're talking about pass by reference, you send an alias of that variable, so that you were just calling it by a different name, but at the back end the variable is the same. So whatever operation you're doing on that variable is actually you're doing on that variable in a true sense, which is present in the global scope. So this was a quick recap of pass by value and pass by reference. And when it comes to pointers, everything is pass by value, but in actual it is not. And what's the reason? To do that, you need to go and check out my previous video on this. Now, first things first, how are we going to generate a random number? So in order to generate the random number, we need to include a library, and that library is called C Standard Library, CSTDLIB, C Standard Library. Now, the function that is inbuilt in C++ library, C Standard Library, that is called rand function. As you see that it's already there, and if I just write its prototype, I have been presented with this return type as well, so we know that it only returns the random number. But before I go into this one, we need to understand, but first let's get to it. Random number, this is the random. Now this function, just by merely calling it, it's going to generate random number. But you know, in our previous video we also learned there are two methods to catch the value generated by a function. So return type is integer. We also need a way to catch the variable, catch the integer that is returned by this method. So to do that, we can form two techniques, which is either by directly see out the number, or you can save it in another variable. So I'll just, in this case, we'll see out the number, see out, and then in the end std and endl. Right now I'm going to run this program and see what I'm presented with. It does it for the first time.
Build started.
Running C++ video.
Build started.
So here is that random number. Now why is it random number? If it were random in a true sense, it wouldn't give me 16807.
Build started.
If I just do it again. So it's 16807. If I run it for the
Build
third
started.
time, again 168. It's for the fourth time,
Build
fifth
started.
time, it's just going to give me the same number. So on different PC, it's going to give a different number, okay? But the thing is, it's not random in a true sense. Why is it called pseudo-random? And if it's not random, why is it called a random number? So if I just copy paste it and I
Build
see the
started.
second time, the number is different. If I run it
Build
again,
started.
number is same. So you see, the more I call this function, the more phases it's going to change. Okay, so different numbers are presented, but again on execution, it's giving me the same number. So it's called a pseudo-random number. How are we going to include a random number in a true sense? So to do that, we take help from our system's clock. And to manipulate that clock, we include ctime, or just say time.h. So after including time.h, I'm going to seed that random function. If I seed that random function, it works. So if I'm not wrong, what was that, man? So srand, I'm going to include time, and then I'm going to include null as a variable. So was it? And then call my function. I think I'm doing it wrong, but let's see, because I'm doing it after a long time. Use of undeclarative identifier. Did you mean time? Yes, I meant time. Let's see.
Build started.
14701. 147.
Build started.
14711.
Build started.
14720. So you see the number changes. Implicit conversion loses integer precision. Okay. So we seed the random function and then generate a random number. What if I try to do this? I think there is a confusion. This invalid binary. Yes, okay. So it's okay. Let's just do it. So you saw that was a pseudo-random number. And since depending on the clock that we have in our system changes every time, so the number changes every time. So it's 148091, 148091, 1482258. So now it's actually getting the time from our computer and then seeding that time into this random number, and then generates a random number depending on that. And since the seconds are changed, so random number. But now if you see that number is too big, what if we don't want this number? Okay, so what do? We use the remainder operator. If I told you earlier, a remainder operator will give you the remainder of a division. So if I say 45 remainder 2 and then STTNENBL and then run the
Build
code.
started.
So 1. Okay, so if you go ahead and divide these values, you're gonna get 44 and remainder 1. So that's how it's done. We are going to use this remainder operator to put a boundary on that number. So if I wanted to put a boundary, so there's a special Control Z. So if you don't understand it, just just have a formula that whatever number you're going to put over this remainder operator, your output isn't going to be bigger than that number. Okay, so if it were 3, the maximum number it could get was 2. Is that okay? So if I wanted to have a boundary on this random number generated and I wanted it to be less than 10, not 10, less than 10, I would do remainder operator divided in 10. So
Build started.
if I run, I see that the problem is solved. Now random number will be generated, but it will not
Build started.
exceed 9. Now 5,
Build started.
3,
Build started.
1. Is it okay? Now we're going to declare a two-dimensional array int of 4 by 4. And by the way, you can use that method that I told you about, multiplication of metrics. You can do that on 4 by 4 matrix as well. Only change you need to do is the for loop. The for loop that goes on till 3 now will go up till 4. Okay, so it's going to be I less than 4, j less than 4, k less than 4. So wherever is 4, and you can change that variable and put the variable over there as well, so that you know how to take input in the beginning. Say what is the matrix you want to do operation on, what's the order of that. So user is going to enter a number. You're going to save that number into your variable, so you know you are manually taking the order, and you can change that program accordingly, so that that program is much universal now, and you can perform operations on a different order of metrics as well. But remember, number of rows of matrix 1 should be equal to number of columns of matrix 2. And if it's not the case, your program should not run. So you know you need to create a whole if statement in which you're going to check in your loop. So you're good in that. So I'm declaring a 4-dimensional array, and then I'm going to do the input process. I'm going to int I0, I less than 4, since my program goes till 4. The loop goes through 4, and now I++. Then I'm going to have another. By the way, if you have a single statement, that means if you want to just see out something, you can just see out it hello. So because it's a single statement, so by default in C++, whatever statement comes right after your for loop, your if statement, if that statement is 1 only, then you can have the independence of not putting the scope. But I say that it's a common practice, and it's a good thing to put your brackets. Always put them. Use these brackets because it's a best practice out there. So you can have another int. This time it's going to j, because we want to use both variables inside the loop. So it's going to conflict, which I was the one I was talking about. I'll just show you in a bit. I'll use I here too, and I'll use I++. Then scope, I'm going to cin, std cin. Oh wow, it's a true sin. So cin, and then arr. Now if I put I here and I here, because one I is from this loop and one I is from this loop, so compiler, even us, we are getting confused which I to work upon. So we use different in this case. If you don't understand, if you want to revise it, you can do that by checking out the last video. So now it's going to take input, and in the end, oh right, this program was not about taking input, was about giving the random value to this. So now each time I want to have a random number, I'm going to generate a true random number, and then I'm going to send time as and then null, and I'm going to do this, and I'm going to have a random number, and then I'm going to divide it by 20 because I don't want any variable, any literal to go above. So not this, ARR, then I'm going to put I and J so that they can traverse accordingly. Now let's make an output loop for statement. Let's have int I is equal to 0, I less than 4 because it's a 4x4 matrix. So let's have I plus plus for statement, int j is equal to 0, j less than 4, then it's j plus plus, and then finally std scope resolution operator, arr, then I, then j, then some formatting, then some other formatting, cout, std, endl. Okay, so now if I run, there is no need to take inputs now.
Build started.
Here is it. This time it took 17.
Build started.
Next time it took 13. If I tell you what's wrong with this program, actually it all has to do with it's something to do with the computer speed these days. It generates, because the time, the seed that was taken was at that particular instant, and it couldn't generate the random number in true sense. So what should we do now? I think this may gonna solve the problem. Instead of seeding the time in this case, just seed the last value, I and j. You can seed anything. I mean, you can seed another random number. Go ahead and seed another random number. That's how you're gonna do random number and a random number. Okay, now run the code.
Build started.
There is it now. It's synchronized. It's not taking that second from the computer, and the very next moment in next iteration, it was so fast that the second it took in was again the same, sort of. So it would have been done like this. It's a simple thing that I understood on my own. So if you want to do something like this, go ahead and check, and if you that doesn't work, you can do it this way.
Build started.
But I think it's going to generate the same thing afterwards.
Build started.
13, 18, 15, 6. So now how are we going to solve the problem? I think my previous solution was the good one. Go ahead and seed I. Let's see what happens.
Build started.
Triple one and the triple one, and okay. So whatever I'm seeding, since I remain constant in iteration in a row, so it's doing this problem again. Then what is the possible solution to this problem? Does anybody have a solution? Since this is going to generate a random number, I can put in the last value. That is going to be a random. I and j minus 1, the previous number to that. Let's see, now this time does the loop change?
Build started.
2, 2, 2, 14, 14, 14, 18, 18, 18.
Build started.
Okay. So it's a real problem, guys. You cannot generate this number, but I am determined to do this right now. So I'm going to close the video now. I'll meet you at the other end when I finish this fight with my compiler, and I promise you I'm going to generate that random number in a true sense in this iteration. So meet you at the other end. Do not shut down this video. Stay tuned. So here I managed to generate a random number for this whole thing. What I did in this program was generating a random number from the time. So each time you start the program, time is going to be different, and each time the seed is going to be different. So seeding, when it's different, it's going to generate a random number that is going to be different. Now with each random number, I'm going to generate another seed for this random number, and that random number is going to add 1, increment 1 each time it runs. So the seeding is increasing by 1 each time on each iteration. So it's 16 times it's increasing with the whole program. And then that seed is going to generate another random number that is going to be below 20 and assign the value on that particular entry that we wanted to give on. So here is it.
Build started.
8, 15, 2, 9,
Build started.
7, 14, 11, 18. So we did it together. Go ahead and try. The second thing that I wanted to teach you today was default arguments. I left it in the last program. That should have been done because it was an important thing to do. So I'm going to delete this program now. So if, say, I have a function, save all Swift, so void function fun, say it fun, and then the arguments are int I is equal to 0, sorry, I, and then int j. I have two parameters and I just want to see them out. I want to see them. What are the variable? So I'm going to do I'm going to do this space, blank space in between, and then j, and then std, and then entl, right? Oh, I need to have this. So I just want to see them. Now depending on, we want to say that we don't want to give j a value. We want it to behave both ways. Either we give it a value, either we don't give it a value, but we still want to operate it. But you know that we have parameters and we cannot go just walk away from giving the j a value. So there is a method you can do this. You can make a default value. You want 12, so you can give it a 12. Now on my call to function, if I just give it one value, that is 12, and that is sorry, on I, that is 2, I do not want to give j a value. Go ahead, do not give value to j. We see that in our function 2 was the value that we passed from the main and 12 was the default value in this function. Now remember something that is standard. Whenever you are giving default values in a function, make sure that you place them on the back side, on the other side. But you can also give them a default. You can also cancel a default value by giving your own value.
Build started.
And then just run. You see now this time it's 211. Okay, you can give it 10. In this case, your default value will cancel. But if you don't want to give it, you just give it 23.
Build started.
And you see that the first value is 23 and the second value is 12, which was the default value. So whenever you want to give default value, keep them at the back. So this was all for today's programming lecture. Till then, seek smile, stay smiling. Allah Hafiz.